All right, we are starting electrostatics, or basically basic information about static electricity. Remember, static means stationary. You are going to want to actually have the notes downloaded. They're in the My HB immediately above this video. So let's define electrostatics. Okay, it's the study of an interaction between charged particles. Okay, so one of the big pieces of this is also that those particles in this part of the unit, in this unit, we are going to be thinking of as being completely stationary. There are two types of charges. Those charges are either positive or negative. These are terms that were actually coined by one of our nation's early leaders, which would be Benjamin Franklin. Okay, and Benjamin Franklin created these terms and this view of electrostatics, which we call the traditional view, back when he was doing static experiments in the 1740s, so well before he became an elder statesman during our American Revolution. Okay. He described the positive charged particles as having an excess of what he called an electrical fluid. He described negative charges as having a lack of this electrical fluid. Okay, today we know this was wrong, but remember, this is before we understood that atoms were separable. Okay, we didn't realize at this point that there were parts to an atom. Okay, atoms were a whole thing. All right. So I want you to be aware of the fact that these ideas and terms were coined and actually extensively studied prior to our modern understanding of how charging works and our modern understanding of the electrostatics. So we keep all of these ideas and terms based on the traditional view, which was the one that we used and studied everything under. Okay, so again, we continue with this idea there are two types of charges, but now the modern view is the one you're way more familiar with. Okay, there's parts to an atom. Right? These parts of an atom are the protons, electrons, and neutrons. The protons are inside the nucleus or near the center of the atom, while the electrons are moving around outside of the nucleus. Protons are positive, neutrons are negative. Electrons are negative, but there's also something called a neutron, which is a neutral particle found within the nucleus of the atom. Okay. We still consider the proton to be positive because it matches what Franklin's description of how positive things act. Nowadays, we recognize that something being positive means it has more protons than it does electrons. Okay. We call something negative today, okay, because it still matches Franklin's descriptions of how negative particles interacted with the rest of the universe. But today we understand this rather than a lack of electrical fluid. We know that this means that something has more electrons than protons. Okay. So, notation note, this unit can have an incredible amount of E. Okay, the letter E is used extensively, and so I want you to know what I'm going to be talking about when I'm using the letter E. Okay, lowercase e with a negative superscript represents the electron particle. Okay, a lowercase p with a positive superscript represents the proton as a particle. Okay. Now, the thing we're going to kind of end with today is this idea that charges are quantized. They can only have certain values. You can't take half an electron from an object. You can't put half an electron on an atom. Okay, we can only have the charges of removing or adding a full electron at a time. Okay, now in chemistry, you absolutely measured the charge based on the number of electrons you either added or removed. In physics, we're going to use a slightly different unit for it, okay? And in order to do that, we're going to have to come up with, of course, an equation because it's physics, right? And that equation is that the charge, which we represent by the letter Q, is equal to N times E, or the number of electrons that have either been added or removed, times the charge of each electron. All right, so let me give you a chance to copy down all of these values. Okay, now that you're back, keep in mind the word magnitude, okay, means the absolute value of. This is telling you the numeric value without telling you whether it's a positive type of charge or a negative type of charge. You are going to need to determine that by whether you've added or removed electrons, okay? So to help with that, I think a problem is helpful. Okay, so let's do, before we get to the problem, some reminders about all of this. Opposite charges attract. Like charges repel each other. These are things you have been chanting since you were probably like 7 or 8. Okay, neutral particles, like dust or like little tiny pieces of paper that are torn up, are actually attracted to every type of charged particle because they're made up of atoms, and those atoms have electrons and protons in them, and those electrons can move around a little bit, so they can redistribute themselves a little bit to have, it's a much more mild attraction, but there is some attraction for all neutral particles to a charged particle. All right. Neutral, again, means equal numbers of electrons and protons. An excess of electrons would mean that it's negatively charged, and a deficit of electrons means it will be positively charged. Okay? These are things that you have to think about. Okay? You have to determine whether it's a negative charge, a positive charge, or neutral, and that's where you're going to use determining the type of charge you have when you're using that equation. Okay, so our example. You have a metal sphere that has an excess of 125 electrons. What is the charge? We're going to start with the generic equation that the magnitude of Q is equal to NE. So I'm emphasizing that as of this point, I'm thinking of it just as magnitude. I have not yet addressed the fact that it's an excess. I'm just addressing that it's 125 electrons that are going to be involved. 125 electrons, and each electron has a charge of 1.602 times 10 to the negative 19th. Yes, it is negative, but again, remember, we're talking absolute value here. Okay? Now, excess charge means the charge itself is going to be negative. So I'm going to remove the absolute value sign by adding in the negative sign on the right-hand side of the equation. So the charge of a metal sphere with extra electrons would turn out to be negative 2.0025 times 10 to the negative 19th. When we round for sig figs, we get our negative 2.00 times 10 to the negative 17th coulombs. All right. This is going to end our new notes for today. I would like you to work on the electrostatic problems, and I know it's called supplement, but they're the problems that are on our MyHB, and I'd like you to work on numbers 1 through 4. I want you to think about it. You may find it helpful to draw a picture, but I'd like you to try those as well. Thank you.